So, the orals on page 439, I'm sorry, guided practice, page 439. We're going to start with number 1. Number 1 says, the graph of a linear inequality in two variables is called a, the answer to that is actually found on page 436, bottom right. Those of you that were here yesterday, I also talked about it several times in the video. And it says this on page 436, bottom right. The boundary line divides the plane into two half planes. So half planes is the answer, or half plane is the answer. When graphing, this is number 2. When graphing a linear inequality, you've graphed linear equations. Okay, it's where you have the solid line. When graphing a linear inequality in two variables, explain how to determine which side to shade. I am going to do a sample, that way you have yet another example to help with that scenario. Okay, first off, a couple of things. A linear inequality is when you have a less than, greater than sign, less than or equal to, greater than or equal to sign. Okay, those are the 4 signs that create something called an inequality. Equality is equal, inequality is not equal. Okay? In order to graph these things, here's the technique. Let's just say I have y is less than or equal to x minus 1. When I laid out the lesson, the first thing I showed you is to think of it as y equals x minus 1.
Would Praise Team D please go to the gym? All Praise Team D members. Thank you.
Now that it is in y equals some slope multiplied x added to the y-intercept, now that it's in that form, we are going to simply graph the m value and graph the y-intercept. The m value, since there's nothing in front of the x, what is the m value? 1, bravo. That means the slope is 1, 1, 1, 1, 1. The y-intercept is negative 1. All right. So I'm just drawing part of a graph here. Okay. Here is my y-intercept. Right? You can kind of see that this is 1 space down. Okay. Up 1, over 1. Using the slope to find another point gives me that point. Now, if it were simply a regular equation, you would draw a solid line just like that. Okay? And you'd be done, as a matter of fact. But because it is an inequality, you need to make a decision on what kind of line to draw. Less thans and greater thans receive a dotted line. Less than equal to, greater than equal to receive a solid normal line. Okay? So we've graphed it here. Now I'm going to use less than equal to choose. Do I have one of these? No. Do I have one of these? Solid line it is. Okay? Now that I've chosen the line style, it's solid, almost done. Pardon me, that's not very pretty. Okay, the final step. So first, solve it as if it's an equation and graph it. Step 2, determine what kind of line to draw. Step 3, what kind of shading. What do you mean, Mrs. Myers? Well, yesterday, the Math Olympics didn't see this, but you guys saw that in order for something to be smaller than or bigger than something, that means anything that fits on either one side or the other side would continue to reflect a true statement because we're talking about something bigger than. So give me another number bigger than 1.
2.
Anything else?
3.
Anything else?
4.
Infinite number of possibilities, right? Same would say if I said give me a number less than 5. infinite number of possibilities, which is why shading is required, because whether you shade this side or that side, you are saying anything that goes this way, infinite, would be true, or this way, infinite, would be true. The question is, which side do we shade? And here's how I test. I use a test point, and this happens to be 0, 0. Would you agree? If the 0, 0 is on the line, you can't use it. Okay? You have to use something else. And you can pick anything else on this side or on that side. Now, here's the rub. If I choose this test point and I plug it in, if this test point makes a true statement, then everything on that side makes a true statement. If this test point makes a false statement, then everything on the other side must be true. Okay? So 0, 0, plugging it in, y is 0, is less than or equal to 0 minus 1. Okay? 0 is less than or equal to negative 1. Is that true or false?
False.
It is false. So will I shade the side that includes the false? No. The other side gets shaded. Okay? That, my friends, is the brief answer to number 2. How do you know what to shade? And first off, you graph it like it's equal sign. Second off, you choose the line style. Third off, you use a test point. If the test point is true, shade that side. If the test point is false, shade the other side. This time we learned the test point was false, so that side is false, the other side is true. Moving on. 3, 4, 5, and 6, we are asking ourselves whether or not these ordered pairs are solutions. First I'm going to write the thing. It's 4x plus y is greater than negative 1. I don't know where that greater than got crazy. The first pair is negative 2, 5. Okay? I'm going to plug in the negative 2 as the x value. The 5 is the y value. Okay? Negative 8 added to 5 is greater than negative 1. Negative 3 is greater than negative 1. True or false? False. Does everybody see how I plug these in? Jada, are you with me so far? Rach, I know you guys are. Here's the points. Plug them in here and here. Solved 4 times negative 2. There's your y value. I combined and determined that no, it is not a solution. Number 4, exact same thing. Same pair, or same equation, same inequality, different pair. 4 times 0 added to 0 is greater than negative 1. 0 plus 0 is greater than negative 1. True or false? Indeed it is. True. Number 5, same inequality, new points. 4, negative 4. Okay? 4 times 4. Added to negative 4. Greater than negative 1. Okay? Awesome. 16 combined with a negative 4. Some of you have already seen it. 12. True. Yes. The last example that is just like this, that will cover items 16, 17, 18, and 19. Here we go. Number 6. Negative 1, 3. Using the same inequality, 4 times negative 1 added to 3 is greater than negative 1. Negative 4 plus 3 greater than negative 1. Negative 1 is greater than negative 1. No, ma'am. Okay, no good. Okay. 7, 8, 9, and 10, these are all examples that will help you with numbers 20 through 31. Okay? Sorry, this is going to take a while, guys. 20 through 31. So here's number 7. It says, the instructions state, graph the inequality in a coordinate plane. Here's the first one. Y is less than 3x plus 1. Step 1, graph it as if it's an equality. Y is equal to 3x plus 1. Okay? So, what's the y-intercept? 1. I'm just drawing this upper half here. Slope? 3. So I'm going to go up or down 3, right 1. Okay, there's step 1. I've provided my points. Step 2, style of line. It is dotted because on the previous page and in yesterday's lesson, less thans and greater thans take dotted lines. If it includes the or equal to, it will be solid. Style of line for this, you've already told me, is dotted. So, I'm going to take my little straight edge and create the most obvious dotted line possible. If I can't tell if it's dotted or straight and it's supposed to, or dotted or solid and it's supposed to be dotted, I'm not going to stress about it. I'm going to mark it wrong. 3, final step. Test point to determine shading. Okay? I like to test 0, 0. And as long as 0, 0 is not on the line, it's testable. As you can see, 0, 0 is not on the line, so we're going to plug it in. 0, 0. So 0 is less than 3 multiplied times 0 plus 1. Is 0 less than 1? 0 indeed is less than 1. Therefore, the side that includes the test point is true. Again, if the test point 0, 0, as said earlier, is on the line, simply choose something else. Let's just say it was on the line. I am going to choose, and I'll do a star. This point, you're here. Let's call that 1, 1. Okay, would you guys agree with me? Right? I mean, I know it's kind of hard to see, but that's 1, 1. If 0, 0 is on the line, simply choose something else. I could have chosen something over here, too. I could have chosen negative 1, 1 if I wanted. Negative 1, 1 would have resulted in a false. But let's do 1, 1. Using 1, 1. 1 is less than 3 times 1 plus 1. 1 is less than 4. Again, it's true. Okay? 0, 0 is just easy because people with small brains like me like multiplying by 0. It's just easier. Okay. Number 8. Same exact process. 4x minus 5y is less than or equal to 20. Graph it as if it's an equality. Is it in y equals mx plus b form? No. Just like we've done in the past, we need to move stuff around. We want our 5 to be by itself, so I'm going to subtract 4x. Negative 5y is less than or equal to, your x needs to come first, and your number goes last. Here's the part where you're all going to flip out and probably get this wrong. If you get anything wrong, this is going to be it. What happens when you divide in an inequality by a negative? Not only that, but in an inequality, when you divide by a negative, you flip the sign. Okay? If you have 6x is less than 12, and negative 6x is less than 12, and you divide, I'm just giving you this example, this has nothing to do with the problem. When you divide by a negative, you flip the sign. Okay? Dividing by a negative causes you to flip the sign. So, negative 5 by negative 5 is just y. We divide it by a negative. Is it still less than or equal to? When you divide by a negative, you flip the sign. We just divided by a negative. Do we leave the sign the same? We flip it. Okay. Negative 4 divided by negative 5 is positive 4 over 5. We need that for our slope. Up 4, right 5. 20 by negative 5, negative 4. Is it in y equals mx plus b form? Absolutely. Can I graph it now? Yes. Negative 4 is our y-intercept. So I'm graphing the lower quadrants. Negative 4, 1, 2, 3, 4. Up 4, right 5. 1, 2, 3, 4. 1, 2, 3, 4, 5. Wow. Ran out of room. Okay. I have now converted it to y equals mx plus b form and graphed it. Style. Is it dotted or solid? Solid because it's and equals to.
Mrs. Meyer?
Yes.
Could I please have Elizabeth to the office to go for the day?
You bet. Solid line. So you've got evens for tonight, my dear. Does 0, 0 look like it's on the line, or can I test it? Yep, part 3 test point. 0, 0. There it is. And you could test it here, or you could test it up here. It does not matter. Okay? So, y is greater than or equal to 4/5 times x minus 4. So 0 is greater than or equal to negative 4. Is 0 larger than or equal to negative 4? Absolutely. 0 is bigger than negative 4, which means the area that included the truth gets shaded. Okay? 7 and 8, the ones we just did, will help you with 20, 22, 24, 26. Those are all identical. Numbers 28 and 30, that will be numbers 9 and 10. Numbers 9 and 10. Okay, here's number 9. X is greater than negative 2. Okay, X is greater than negative 2. Graph it as an equation. X equals negative 2. And we learned about this several lessons ago. If something is always negative 2, then that means the x value never changes. Okay? And on and on and on. That is the right-left value. X, you go left. Graph it, just like we've done in the past. Negative 2. Anything that is a negative 2. Okay, that's all that stuff over there. Okay? Negative 2, 0. Negative 2, 1. Negative 2, 2. Negative 2, negative 2. Okay, all of that represents x being negative 2 and y being infinite number of possibilities. Type of line, dotted or solid? Dotted, because it's greater than. Okay, if it were and equal to, the line got a little crazy. Okay, let's pick a point to test. How does 0, 0 look? Okay, so if I test 0, 0, but all I have is x equals, or x is greater than, then I'm going to use x as 0. Is 0 greater than negative 2? Is 0 greater than negative 2? Yes. Bravo. That means the side that includes the point that I tested is true. This one is identical to number 29 and 30. Okay, identical. Maybe different numbers, exact same thing. Number 10, y greater than or equal to 1. Graph it as an equality. Y is 1. That means as long as y is a 1, anything in the x column is true. The y value is the up-down movement, the vertical movement. So, there's 1. Anything in that neighborhood is the 1. Solid or dotted? Bravo. There's my solid. Can we test that easy peasy 0, 0? Sure we can. So, 0 is greater than or equal to 1. True or false? False. Yes, sir. Sure. Go for it. Shade the side that does not include the false. This one is identical to number 28 and number 31. Number 11, last thing. I know, sorry. Lots of questions. I want to make sure you guys get all the information I can give to you. You have a gift certificate for $40 to use at the movie theater. Matinees are $5. Evening shows are $8. What are some possible combinations of matinees and evening shows that you can use? So you have $40. Would you agree? So any combination of the $5 tickets and the $8 tickets all together have to be less than or equal to the $40 that you have. Okay? All together have to be less than or equal to the $40 that you have. 5x plus 8y is less than or equal to 40. 5 of these, 8 of those. Okay? There's the equation. Let's graph it. 8y is less than or equal to negative 5x plus 40. Different.
Why do we do less than or equal to?
Because can you spend more than $40? But you can spend less than, right?
Like, doesn't it have to all add up to exactly $40?
Did they say you have to spend every drop of money you have? No. They're looking for combinations that you could have to get close to without going over. Which means I can only buy, there might be a point where I can't even spend the exact 40 if I buy 2 of these, 2 of the $8 tickets. So that's why. It can be less than or it can be equal to. Like if you go 4 times to the matinee, that's $32, leaves you $8. You can only go 1 time to the matinee. So let me show you. I'm going to keep going here. Divide by the 8. Since that 8 is positive, do I flip the sign since the coefficient of y is positive? No. Y is less than or equal to, the signs don't change, nothing gets flipped. Okay? Can I graph it now? Graph it as an equality. Y-intercept is 5. And you're only going to be working in positives because you can't buy a negative amount of tickets. 1, 2, 3, 4, 5. Here's the first y-intercept. Okay? My slope is down 5, right 8. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8. Solid or dotted? It's solid, you're right. And it does not go above or below because you can't have a negative number of tickets. Okay? Can I just be greedy and keep my gift certificate for later? Technically, 0, 0 is an option. Let's test it just to prove it to ourselves. 0 is less than or equal to negative 5/8. times 0 plus 5. Is 0 less than or equal to 5? That means this entire scenario can be possible. I can buy 8 matinee tickets and no evening tickets. Or I can buy 5 evening tickets and no matinees. Or any combination in here. Let's look at this, for example. I can buy this, hang on. I might still have some money left, but this I can do 3 of these and 2 of those. Evenings tonight.